Well, I'm Benjamin Celis. I'm one of the senior system engineers from the Mellon Group. Here is also Matt Pollock. We have been working on DECAF. Actually, both of us have been in National Instruments for over 10 years. And we have seen a lot of embedded applications. And one of the things we have seen in common is there's a lot of reused components. And we tend to do everything every time we start. One of the solutions we have for that is what is the DECAF framework. So what I'm going to go through this presentation is talking about a reusable framework that we created in the system engineer group that helps you to address all the issues coming with embedded applications. I will go into details who are supposed to use it, in which applications we want to use it, and what advantages we get from using the framework. So the first part, we could say this is a marketing slide of what is DECAF. DECAF is an open source framework. Everything is under Apache 2 license on GitHub. So all the code that you get from us is free. One of the important things is DECAF is not a product. It's a framework, it's a library from system engineers that can help you develop your applications faster. Now, one of the really nice things is scalable. So if you have an application that, well, how many of you have requirements changes during projects? I mean, requirements never stay the same. And one of the advantages we have with here is it's easy to adapt to that. If there's a change in requirement, we can modify it. We provide a really nice configuration interface that allows you to make changes without changing anything in the code. Many of the changes for small requirement changes will require you just to touch the configuration interface. If it's a big requirement change, you might need to add an extra module. But one of the nice things is it's flexible, so you can add new modules. We need new functionality. You don't have to scratch your code. You can just start building on top of it. Or you have a project that is really similar to what you already finished. Well, you can use a new module and continue using it. And when you switch projects, you can reuse all your plugins. Now, if you don't have a plugin, maybe somebody in the community already made it. We have already created a couple of modules. I don't know who in here has worked with modules. Yeah, pretty much. For embedded applications, even if you try to get away with modules, there will be a sensor that speaks it or something like that. So, for example, we already have a modules plugin. If you're working with that, you can reuse the plugin that we already have, and you don't have to write it from scratch. It already has a lot of good design practices, like how many embedded applications should have error handling? All of them. How many applications have actual error handling? And that's one of the things. When we start with this framework, we already start with some base of error handling. You can work with more of it, but you start with a good base in which we have good embedded practices. We have things that prevent you from race conditions. Race conditions is one of the worst things you can get in an embedded target because if you're lucky, you will find the race condition the first 3 minutes working. Worst case scenario, you deploy a target in somewhere you don't have access, and every 6 months there's a race condition happening, and your system crashes. So we have worked really hard in making things to prevent that. I mean, of course, if you really try to get a race condition, you can get it. We're not tying your hands. If you try hard, you will get it. But it will prevent you from getting simpler conditions like that. And, well, we also have optimized the engine. One of the things we have is an engine that allows us to map everything. I think everyone in this room that have worked with systems, you have input from more than one source. You have to process them and then output them to all other places. So we created a mapping engine that allows you to share that information between all your components. That engine we have optimized. We have some things. When I show you the code of the engine, it might look a little bit more complex, but a lot of it is just optimizations. We are trying to reduce overhead on callbacks, making indexes faster. So that's what we have been doing in the engine. Now, how we're going to go in here is what we created is the first thing. The main idea when we created this was internally for system engineer. I think most of here in Alliance member has worked with system engineering group at some point. One of the main things we do is help those big things. And one of the ways we do that is creating proof of concepts. The problem with those proof of concepts is many of them are really similar. So we will be doing the work over and over again, and we didn't want to do that. The other point is many of our proof of concepts, even if it's a proof of concept that is, I'm showing you it will work. This should not be deployed to an environment. It will end in production line, and we'll get a call, hey, why is this not working after 24 hours? And it's like, it was a proof of concept. It's not supposed to run. And we created many of these things so we can create proof of concepts faster. We can reuse the code. We have system engineers that sometimes receive a project. Hey, I need to do this, this, and this. Oh, we already have all those modules. So a proof of concept that could be a week or two, now it's a 3 or 4 hours proof of concept. Now, when we started doing that, we realized that a lot of what we're getting could be shared with alliance partners, could be shared with customers, and we started lowering the barrier of entry with embedded. I would say building an embedded system with LabVIEW is way easier than building an embedded system with any other thing. Now, building a good embedded system is not that easy, because you have to learn a lot of concepts. And especially new customers have to learn this. They don't know what race conditions are. They don't know the priorities. They must start the engine. I would say one of the most common things that always happen is a while loop without a timing, and it's like, I deploy this, and my compatibility doesn't respond. So we are creating something to prevent that. I would say the idea of this framework is taking the hard part of making a good embedded application and make it easier. We're still working on making it easier. It's still not the easiest way to do it, and it's not a replacement of training. You still should learn how RT systems work. You should still learn good practices, but through these you can learn a lot of good things. If in your company you already have a framework, you might say, oh, we might not use this, but you still can see a lot of the things we did and apply them to your application. Now, who is the target audience of this framework? I would say the first part is new users. I have heard the same story over and over again. There's a new project, somebody has to work with it, they don't really know how to use CompactReal, and they have 3 or 4 weeks to do it. And they don't have time to take all the training that they will require to start doing that. So we have a lot of simplifying things. We have a lot of scripts in which a new user to write an application, even with some custom code, don't even have to write a while loop. They only need to unbundle, make their logic, and bundle the information back. So we're trying to simplify it to that level. A user that is lucky enough that all the modules that they need is already created, they can basically create all the application without writing any specific lab code. And that's the idea. Now, we're not stopping at that, but we're also going, targeting advanced programmers. Why? Because that was part of the idea of it. When system engineering created it for ourselves, most of our engineers are pretty advanced in embedded, and we were wanting to make our applications faster. We have really good customers that have already used this framework. They have their in-house framework. It was working really good. It was fast and everything, but then they tried this. It was 15 times faster than what they already had. So they decided to switch everything to this architecture. So that's what we're targeting both audiences. Now, what is this framework? What are we building with? In general, there's 2 parts of the framework. One is the configuration interface, where you will create and configure your systems, and the other is the runtime part. Now, when we're working on the configuration interface, we have a configuration editor. When we're working on the runtime, we will have an engine, or a runtime engine. And also, you can create modules. These modules live both in the configuration part and in the runtime part. And it's one of the nice things that they will bridge that gap in a way that won't block your system. And this is the part where we start talking about good practices for embedded. Have any one of you have problems of a library or a class being blocked because you have coded on the real-time part and on the host? There's no really good way to get around that, because LabVIEW needs to log it to protect the system. So what we did is we split all our modules into 3 classes. We have the configuration class. This class is really simple. It basically stores your information. It's a cluster that has some methods to read or access that cluster. It has a toString and fromString, so there's no type dependencies tied to it. And that will be the only thing that will be logged. It's simple, so in general you will not be editing it that much, and having it logged won't affect you. Also, in general, in that class, you will not have anything that is RT specific or that is Windows specific. So you will not add read from Excel or write to Excel or the RT parts. So that will prevent you, when you deploy, to have all those extra errors that don't apply because the library completely got deployed to your system. Then we also have 2 other classes. The editor class, you can think of this as the UI that allows you to modify or configure your configuration class. In here, you can add all the Windows things that you want. If you want to work with Excel, you can work with Excel. If you want to work with PowerPoint or read from files, you can design everything that you want in there. And that won't get deployed to your system. So one of the things is, in that part, you don't really care about performance that much. You can make sure your system is working. And finally, we have the runtime class. The runtime class is what is going to be deployed on your system. Even if it's a PXI, a CompaCREO, or another computer, that's the part that will actually be running. When you care about performance, that's the part that you're going to be carrying. Now, one of the nice things of having all these classes too is that you can test or unit test your system faster or easier. You can make sure that your accessors for the configuration work by themselves. You can make sure that the UI works by itself. And you can make sure that the runtime works. In general, for most of our modules and engine, the runtime part, right now, we have not seen bugs in a lot of time. We have been really consistent on making sure it works. Sometimes where we find some minor bugs is on the UI. And the good side of that is it doesn't affect you to the configuration. Once it's deployed, your system is stable. Now, what is this runtime class? The runtime class will already create several overrides for you to work on top of them. It will be as easy as create new override, and actually there's scripts that already override them for you, so you just have to modify them. And we have basically 5 components. Open is where we configure our system. If we have indexes, we initialize them. We get all the search by names done in one single place. If you're opening serial ports, you will do it here. And basically, it initializes your system. This is where all your extra overhead will run the first time the system runs. And then you don't have to care about it. The idea of the read module is anything that is from outside the system into the system. It could be coming from modules. It could be coming from OPC UA. It could be coming from the scan engine. It basically takes information from outside the system and puts it into the engine. The processing module basically reads and processes the information, and then the output basically takes it outside. So you will override the specific things that you have. If you're writing input-output module, for example, scan engine only uses the read and write. It doesn't make any process. But I will get into more detail with that. The main idea is modules are really simple. It's what we're going to be building. A lot of them have already been created for us. And one of the nice things is all this is in the community. So if any one of you is building a module and is like, I want to share it with the community, you can share it with the community. If you're an Alliance member and created, I don't know, a CanOpen module, and there's no CanOpen module, you can actually sell it in the community for other people to use in the engine. So one of the nice things, as I was saying, is we have templates. When you go to the template, you can create new module. And this is the level of code that we're expecting for a new user to write. So what could be complicated on here? Well, as long as they understand what a cluster is and how to unbundle and bundle, the rest of the things basically are taken care of. We have scripts that will take this cluster and plug it into the rest of the engine. So you just have to write the simple logic. One of the things you can notice is there's no payload. And as long as it's not blocking, this will run perfectly into the engine. We're simplifying it, and as we have seen, someone in this level is probably someone with LabVIEW Core 1 and 2. We have a large customer that was at that point. They took LabVIEW 1, 2. They needed to work in the system. We went with them. We showed them the basic of how to use a CompaCREO and how to use the framework in 3 days. And they built by themselves a complete application that is running on another field right now. So it simplifies it to the point of simple VIs. Now, let's talk about a really common application. I think everyone in here has seen something similar to this. We have a simple PID machine. This could be a temperature control, it could be a pressure control, or something simple. Normally, we have some inputs coming from HMIs. We have some inputs coming from inputs and outputs from scan engine or the modules in our hardware. And even if you don't want, there's something with modules. So modules appears again, and you have to work with it. So maybe some of the information comes from each one, and I need the set point, and I need everything into my PID loop. Then once I process this information, I have to send it to the HMI. I have to send it to my IO modules. I might have to respond to the module slave. And finally, I might want to load my information. This looks a pretty straightforward application. It could be really simple to just write it. Also, one way to do it is everything of this could be a loop and communicating everything from CVT. If it's something as straightforward as this, it will work. Probably that would be the fastest approach. But what happens? As I asked before, those requirements changes. Yes, they don't know what they want until they see, oh, that works perfect. Now can you start adding this? So let's add just a little bit of difficulty. We know what our inputs are, we know what we're processing, and we have our outputs. Let's not change inputs and outputs, just let's add something simple. Now I want to add alarms to this system. What will that imply? Well, adding the alarms will require that now I need my inputs and modules going into the alarms. Then I need everything from the alarms going into all the other devices. And what's the problem with this? If I'm using CVT, I might get race conditions because I have to process writing to the same task. And I could continue adding extra modules. And every module I add, it will make it more complex. So how are we simplifying this into the engine? Well, in here we have a single engine. You have your modules, and the modules write into the engine. The engine on the backbone is using a library we have called DECAF. Have anyone here used CVT, the current value table? Okay. DECAF is basically CVT on the wire. It has accessory, it's really similar to what CVT has. The main difference is instead of being a functional global variable, it's a cluster. The advantage of this is first, it protects everything with data flow. We're not telling you use a functional global, because what happens when you tell a customer, hey, everything here is using a functional global. If you need to add anything, add functional globals. What do you think happens with that type of code? They end with a lot more functional globals, and then you start having race conditions. In here we have the engine running on these tacos, in which all the modules write to that cluster and read it backside. It's just a big ugly cluster with an array for every data type, and we're just indexing and getting the information out. The nice thing with this is, if I have an input module, it writes to the engine. If I have a second input module, it also writes to the engine. If I have 20 input modules, all of them write to the engine. So my PID module doesn't need to worry where the information is coming, because it only has one source for the information. It reads from the engine and processes it back in. So that prevents you having to map to all the modules and does it automatically for you. So this engine, what it will do is look something like this. You initialize all your modules. If the modules in general won't have all the three options, some will only have inputs, some will only have outputs. But for space in the slide, I added both of them. All the inputs go into the tacos. Then the process reads from the tacos, and it basically will sits a for loop with a shift register. The information will go through all the process. And then it goes all at the same time at the out. This is the ideal scenario for a control application because, one, you know when things are executing. You know all your inputs are fresh when you're making the processing. And you know all your processing is done when you're outputting outside of the system. This gives safety and gives stability to your system. Now, how will this look into the code? This is a screenshot of the engine. It has a lot of extra stuff. A lot of it is metrics to make sure you're executing it on time. But really the important thing of the engine is these three VIs here. This one is calling all the inputs, then it calls all the processing, and then it calls all the outputs. It's just a for loop that executes all your modules inputs, processing, and output. Besides that, it's just a big while loop. Now, one of the most confusing parts, and I would say the tricky part, and most of it is because naming, sometimes getting the name right for things is not easy as it appears to be. And well, in the naming convention we have here, originally we were like two engine or two module, or from engine and from module, and it becomes really complex. So in terminology, we are using two terms. Attack is basically a variable that lives in the engine. It's engine scope. Basically, all our tags have data type. So you define if the tag is a double, an integer, a boolean. They have a unique name, so you cannot duplicate tags. That prevents you having race conditions or unwanted behaviors. And this is one of the key things for preventing race conditions. You can only have one writer for a tag. So one module is the only one that can write to a tag. You don't have the problem of, oh, module 1 executed, but module 2 didn't, and I don't know what's going on. Only one module can write to those tags. But at the same time, you can have multiple readers for the tag. Yep.
But you have inputs and process, like the write to it.
Yeah. So the thing is, all the inputs are writing to different tags. All your modules could read those tags because that tags can have multiple readers. But when writing back into the engine, you can only have one writer. That prevents from modules overwriting the information from another module. And preventing problems like, oh, I executed the modules in different order. Now things are not working. Now, if you had two modules that need to write to the same output, the right way to do is you have to arbitrate that with a module. You have a module that decides if module A is writing or module B is writing. But the actual output is only written by that deciding BI, instead of having two modules and fighting for who is writing the application. I have been on the field troubleshooting for 5 or 6 hours later. Hey, this is working perfectly, but then we have spikes on the signal and we don't know what was happening. And it was because when they were copying the compression from an Excel file, they duplicated the name of a tag, and they have a process that runs every like 1 hour that was writing to the same tag that our process that writes every second. So everything was right for 1 hour, and then we see the spikes and the system went out of control. With this, you prevent that kind of things. And that's why we're trying. If you have errors, you will see them in configuration, and you won't see them outside in the middle of a polar storm while you're freezing. Now, the second part we have is channels. Channels is basically the same thing as the tag, but they live at a module level. Inside of your module, you can have your channels. Their module scope, they have a data type, and they have a direction. Similar as in BIS, you have controls and indicators. In here, they can be an input or an output. And what we will do is all our channels from a module are mapped into a tag into the engine, and then the other modules can read and write from that tag. So this is the main RT code. Looks complex. One of the nice things is you don't have to write it. There's a project template that already scripts all of these for you. We have 2 of them right now. This is the simple one, and there's another one that already has a queue message handler. So you can, for example, reload the configuration. The main thing here is we have an API to control the engine. So if you already have your process or a state machine, you can make these calls to happen inside of your engine. We're just getting the configuration, starting the engines, and this is a really nice thing. We have engines. So right now I have only been talking about having one engine. You can have multiple engines on the same target. We can do that because if we were using CVT, they will have conflict of name tags. As they're using Tagos, which is a local cluster, they can have repeated system. So if I'm having one controller controlling several machines, I just have to make one engine basically, duplicate it 4 times, and then I can have that same system controlling my 4 different machines just by changing the configuration. So the other part that I was mentioning is the editor. In here, as always, we don't really care how much time it takes with UI. UI is not the main thing, but at the end it takes taking a lot more time. So lately our effort has been making the editor look nicer, easier to use, and make configuration easier. This configuration editor is based on another library from system engineers that is called CEF. So even if you're not using the complete framework, CEF is really nice for creating editors. Last year I had a presentation of that. All the information is also on the web. But let's get a little bit into a demo. It sounds good, but how do it apply to me? So the first thing we will see is I can come here to Tools, DECAF, and I will have the Launch Standard Configuration Editor. When I do that, it will load this screen. It's a simple configuration editor. I have here my system, and I can start configuring my system. So let's say I have a PC. So I can come here, add a PC. Then on this PC, I can come, add a standard engine. So this engine is now a process that is going to be running on my computer. And once I have that, I can start adding modules. So right now, for example, I want to add a scan engine, or I can add CVT, or I can add UI reference. UI reference is a module that we have that can read and write from single BI terminals in the front panel. Now let me open a configuration I already have loaded. So one of the nice things is you save the configuration. In here I have a really simple configuration. It's a temperature chamber. Actually, if you go to the Tools Network Pavilion, we're having that demo working in there. But right now in here, I don't have any compact reef. So let's go a quick look at what I have here. I have my standard engine. I have my controller logic. And as I don't have hardware right now, I also created a chamber model. It's basically a simple control simulation. But I don't even have a compact reef to run this in there. What can I do? Well, the only thing I need to do is drag this engine into my PC. Now I'm going to specify that code run there. I can save my configuration, and then when I come now to run in my host name, this is the VI I showed you in the slide. The only difference is I also added here my UI. I can click run, and it will be running with my simulated signal. Yep. So I'm running it, but I have no communication. So the main problem right now is here in the UDP module. I can specify the configuration. And now let's try to do that again. Let's see. Sorry.
Wouldn't be any fun if we didn't have a bug in a demo.
Yep.
That's not an NIWeek without it.
Yep, I'm using the Wi-Fi here. Oh,
Dangers of connecting to a public Wi-Fi.
yes.
Changes RIP.
So the main thing is changing the configuration. I can change the configuration of how my system is working. It allows me to run several engines on the same system, and I don't really need to touch modify the real-time code. What would that imply? If you have several projects that are really similar, you can even have the same exe for all of them and just update the configuration file. Now, one of the main questions with the framework is, where should I use it? Will the framework be used for any application? And I would say no. This is not a framework for any embedded application. If you're working with real-time tests, you should go with Veristat. If you're doing machine control monitoring, you should go with Insight CM. The space in which we're using DECAF is for machine control and machine automation. That's the best fit. In general, anything in which you care about the last value, or basically the tag value, and basically that's what you need in control. So you should use it for type-based applications. You should use it if you already have modules that you want to reuse. So for example, if you already created a nice module for connecting to a network of a company that has their custom protocols and everything, you can reuse that module for other things. Now, this architecture doesn't have to be the main part of your program, but can be the part that manages all your tag communication. It provides a nice abstraction layer. It basically, if you need configuration, we already have a configuration editor that you can use, exploit, or modify. Anything that is machine control or what is system automation. Now, there are some corner cases in which you might use it. One of the proof of concepts I had, and I was testing how to use the system there, was a power monitoring application. Now, power monitoring requires high-speed acquisition, right? I need to be measuring the waveforms from the power lines at high speeds. Now, why did I even decide to use that in there? Well, one of the requirements from the customer is they're using models. So they were validating hardware, and they have an Excel spreadsheet with a models plugin that needed to communicate to the system. Now, when I asked them, okay, what ports do I need? Is, oh, we don't know, we need to change that. So needed an easy way to modify the configuration without changing the application. Also, this customer that was doing that didn't know how to use LabVIEW. So they needed to be able to change the ports, change the configuration, and they didn't know how to use LabVIEW at all. So what I did is basically, I had my data acquisition loop running at high speed from the FPGA. Basically, I used the waveform acquisition library, get all the information from the FPGA into my RT code. Then I had a processing loop, and that processing loop was getting all the control information, all the power information. It was getting me power vectors, it was getting me gain, offset, and all those things that was what I actually cared. But what about those values? Well, I only care about that values. I only care about the latest value. I don't need to be something at high speed. So I published that using CDT into the TAGBOS engine, and then I was sending everything into Modbus and a TDMS file, so they could have all the information stored. Now, as I said, one of the nice things is we have project templates. We have project templates for both creating custom editors. If you're creating your application and you're using the custom editor and you don't want it to say DECAF configuration, but you want to say project X configuration, you can modify it, create your own, and make it look as you want. You can modify it and add extra features. If you need to import files from a custom file that the customer is using, you can do that. You need to write the code, but you can do that and modify your custom version. We have engines. Basically, it's the simple engine and the advanced engine. And finally, we have the editor, the modules. We have already templates for the input-outputs, and we have a template for the control module. That template is the one that allows you to generate the file really easy. So one of the first things, I don't know how many of you have used classes in RT or classes and tried to build them in EXEs. So what is one of the main issues, especially if you think your classes as plugins and that they can change? Yes. So right now, one of the ways we found to get around that is we have a scripting VI. So when you're using the configuration, in the configuration editor, you can come here to Tools, Script Include VI. You can specify what VI I'm including. So for example, I can have my host Rio includes. I can specify that I'm using the host. And click OK, and that will script everything for me. Basically, it's putting all my VIs into a VI, basically dropping the constants in the block diagram. So now when I click Run, or when I build an EXE, they're statically linked, so I don't have to worry what to include. The other part we have is the module scripting. So I showed you that a new user only has to write an input-output simple VI. So in order to do that, what they need to do is go to Tools. No, that's still building. So you will have to go Project, create a new project, create a custom module, and modify your cluster. But what happens? Requirements change. So your cluster with the 5 inputs you defined at the beginning is no longer good. You need 7 now. So with those 7 that you need right now, what you will have to add is come and modify this VI. I mean, it's a trivial VI. What this VI is doing, it just takes information from the tacos and then passes it, gets the index that I got in the initialization, and passes all the information to the output. But when you have a big cluster of 20 elements where you're changing it constantly, it becomes tedious more than hard. We have a script utility in which you specify which is your cluster. So you just modify the cluster over there, the data cluster, click Run, and it will script these VIs for you. So actually, no, that's on your screen.
Yep. So the reason why we had the problem before was his computer still has his firewall set to not trust this network. I clicked the button, so please don't hack me. The trouble is the UDP comms. But what we've got over here is that user interface running correctly. Change your set point, you'll see the system change behaviors. Biggest piece about here we wanted to show was the complexity of the user interface VI is pretty darn trivial. So if your users can write this, then you can get this set up. Takes away one of the biggest complexities in getting these systems operational. We take care of the mapping and the data transfer portions for you, so you don't have to worry about it. You worry about your processing, we'll take care of the rest.
Okay. So another important thing, especially as we have Alliance member here, is everything is on GitHub. So if you want to use this, you can go to GitHub, and you will be able to see all our source code. You can get the latest builds from there. Now, our actual tested build that we make sure that it works, you can download it from Tools Network. Just go to Tools Network, search for DECAF, and you will be able to download here all the information, all the modules that we have. Now, one of the things we had before is collaboration with Alliance partners if we want you to be able to write code here. So, as different with other libraries, in here we're using an Apache 2 license. So that basically means all the code is free, you can modify it, as long as you include the Apache 2 license. And also you can build products on top of that and sell them. So one of the things we're expecting is the community to start working more and creating more modules. Actually, we have right now an Alliance member that is building a module for DECAF. He was building it for his application, but basically it's a module that reads front panel terminals from FPGA and allows you to communicate to the FPGA into the module. Once he finishes it, it will be on the community. But that's part of it. Everyone can collaborate. You can also, if you find a bug, you can submit it here. So let's say you find a bug in Tag Editor 4 on the TMS file. You can go here in GitHub. Just, you have it open?
So if you find a bug on a particular module, just come to github.com/LabVIEW, find the module. We've got a lot that we're working on. Find the one that you want to report a bug on. Oh, I don't know, maybe it's going to be the LED module that I made. Sorry, I might have a bug. Come over here, report an issue, hit new issue, and tell us what the bug is. Just go right to us, and we can work on it. Or if you want to, it's open source. You can work on it and post it right up here for us to include.
Which, actually, that's a really good advantage because you're not tied on our time to fix bugs. You can get the bugs fixed, and now you can use it, and you can continue using the base packages without having any branch or anything particular in your code.
Are there examples that you'd highlight that you could just point out to me pretty well?
The what?
Is there a recommended example or two that you could point out?
For modules?
Yeah, just to get up to speed with it.
So some of the easiest modules are the scan engine module, the tag select module. The LED module is also pretty simple.
LED is about as simple as it gets. It
So-
blinks an LED.
Yes. That LED module controls the LEDs in front of the compact reel. I mean, you want people to know that the program is running, right? So a simple way to do it is you drop that module on your configuration, set how you want it to be blinking, and while your program is running, it will be blinking. But also the nice thing is that blink is controlled by a tag. So you can change that tag in other parts of your system so you can send warnings and basically control the system with easy.
We also have an example that installs when you install the DECAF core component, which is up on VIPM now. It gets installed in your LabVIEW examples folder. It does show up in your example finder. Just search DECAF, it's there. And we've also got a walkthrough of that example posted on our webpage as well. I don't know if you're going to talk about that.
I just wanted to advertise the way that you guys manage trees in configuration editor framework is superb, and I ripped that part off. I mean, if you for nothing else or care about nothing else, just that alone is worth
Yeah. That's the main idea. All the libraries that we have here, if you can use it completely, that's great. If you cannot use all of it, at least we have a lot of components that are easy to reuse, and that's the intention with system engineering, is that you can reuse code. This is not a product, as I said before, but it's for you to make more programs and more projects with compact real faster. So,
Benji,
yeah.
you say compact Rio, but it does support other targets.
Yes. So you can run DECAF engines, both in compact Rio, PSCs, EXI, CBS, basically any target where you can run you can run it. Because one of the nice things is everything is built in LabVIEW. So we don't have any magic black boxes that you cannot modify. There's no code locked by passwords. Everything is open. If you know how to modify a VI, you can modify it. So in general, where do you want, as I said, there's some cases you might not want to use it. So if you don't want to reuse code, don't start here. There's a lot of reuse. You're not interested in that. Now, if you want to write a custom application for every customer, and you want to figure out which customer is, and remember which application, and have all the stack of manuals documenting all your applications, don't use this part. If you like race conditions, go with variables or any global resource. If you like configuration errors, like copying everything in Excel, having 1,000 channels in Excel and making mistakes, don't use this part. One of the nice things with the configuration editor is that you can add safety. You can make validation checks on individual modules or at system level. And also, if you need to work extra hours in a project, I mean, if you have like, I have to work 80 hours and I cannot finish in 3 or 4, then don't use this module. It can save you time. So if you're careful of extending your time, it's not the best option. Now, some of the most common questions we have heard about is, what about performance? Benchmarking an application like this is not that simple, especially because it will depend on the modules you're using, the type of tags, number of tags, and the target that you're using. What I can say is code that has been written with without this framework has been refactored to use the framework, and it has been running 15 times faster with this. We have made some benchmark tests on a 9068, that's basically our bottom line compact reel, with 1,000 tags at a 1 kilohertz loop. So that's pretty much good for most machine controls applications. It can run faster, but we haven't tested and we cannot guarantee that it will run faster. Or in bigger controllers or with different numbers of tags, you can run at different speed levels. One of the other questions is also, how do I debug it? The engine that I showed you might look complex, and I cannot really debug all the parts. Well, one of the nice things is that everything is really modular. So you can test the modules by themselves outside of the framework. You can create unit test frameworks for that. Lidan is here, has been writing that and can tell you about it. Basically, you can run the VI by itself without the engine and make sure it works. And then if it works outside, when you put it in the engine, it will work because it's just reading and writing from a cluster. That's part of the nice thing with this. If you know how to debug LabVIEW, you can debug this part. And you can debug it outside of the engine. So you can put control read and write, or just control the taggles, what's going into your engine, and make sure it's right, the runtime will work, without having all the complexity of a framework for testing. Which also brings you that you should unit test on your system. Some of the modules we have already have some testing. We're cleaning the tests so they're easier to reuse. The other thing is, everything is in the community, so you have all the things in GitHub. You will see what are the issues we have found. And I would say, one of the nice things is you know how to work with this. So even if you're working with AE might not be able to tell you, hey, this works like that in the framework. But if it's a LabVIEW issue, they know how to fix a LabVIEW issue. Also, one of the things is, all the loops are running. The engine that I showed you is a single loop, right? And we have learned in all the RT classes that we should have multiple loops. Well, that's relatively true. I would say sometimes we go with the excess of adding more loops that we need, which makes it harder and brings up the big question that I don't know if we have ever figured out with the CLA summits and all the discussions. How do I stop multiple loops? I will not start into that discussion. There's not really a good answer. But if you only have one loop, it becomes really easy to stop. Now, sometimes you cannot do that. So let's say you have a plugin that writes to a file. You don't want to do that on your deterministic loop because you might lose control of that. Well, if you have a module like that, what you have to do is come to the standard engine, go to your module configuration, and click this execute asynchronous loop. This basically will spawn a different thread for your process. It will be running outside of your loop, and your loop will only get the latest value whenever the other process has the latest value, without blocking your engine. And the other is, how complex is the engine? Well, I would describe the engine as a while loop that contains 3 for loops, one for inputs, one for process, and one for outputs that are constantly running. And then we added a lot of stuff on top of it to make it more efficient or to get performance improvements or benchmarking a lot. So if I want to benchmark the engine, so one of the things you can do is in primary configuration, I can create timing report tags. This will create my tags. So I know if the engine is running late, what is the index count, which is the loop time I have, and it was just a single click. So anyone have any other questions?
I don't think if I missed something earlier, but how you handle race condition. In my understanding, the way you write to the tag pass, you have another layer who will decide who wrote first.
So the thing is, you can write, there can only be one writer to attack.
Yeah.
So there cannot be a race condition because race condition happens when two things try to write at the same tag. Also, you're controlling when things execute. So we'll always execute in a specific order. So there's no possibility of a race condition. Yes.
So for example, you have two modules trying to write to the same tag.
That cannot happen.
Oh, okay.
The conversion editor prevents you from doing that.
It will not let you configure two writers for the same tag. Once there's a writer, it's filtered out of the list.
Okay.
If you have one module that reads the output of a previous module, is it reading that value or the one from the previous value?
In that case, if it's a processing module, it will get the... So it will affect the order of execution because each module writes to the tag loss, and then the next module reads from the tag loss from what it was right. You can control the execution order also directly on the loop. So if you come in to the module configuration, you specify the execution order with priorities.
And bear in mind, it's not a race condition there, but it would just introduce a cycle delay for the next module to get it.
Yep.
What is the data communication method on real time between modules? What do you
Wire.
use?
Wire. I'll add you closer.
Right, but if you have parallel while loops, are you using a queue or are you using...
Oh, so when you're using, so if you have two engines, right now what we have is a UDP module that communicates them. If you're writing with asynchronous tag that I showed here, it's basically using a really efficient trick with RT5 using DVRs and switching the pointers. So you can go into the code and see how we're doing that. That's basically to prevent any memory allocations and maximize the speed of the engine.
So the backbone is RT5, basically?
That's for the asynchronous communications. If it's just a single process, the backbone is a cluster.
Okay.
So-
Yes, of course.
The most efficient transfer mechanism in LabVIEW is a wire. That's what we use in almost every single case in the engine for that reason.
For a single process, but between processes, you're using RT5.
When you spawn an asynchronous thread, and only when you spawn an asynchronous thread do we do that. Typically, by default, there are no asynchronous threads.
Oh yeah. So we're having a hands-on after lunch in the 16B. So if you want to test the framework and play a little bit more and see, oh yeah, everything that Benjamin told me, let's see how it works. We're having a hands-on. We have, I think, like 30 computers. So we have enough space. So if you want to learn more, please go there. Also to get started, you can find everything from DECAF in ni.com/DECAF. You can also search DECAF on the Tools Network to get all the packages. To get other tools and other reference designs from system engineering, you can go to ni.com/reference designs. And again, I have to repeat, this is not a product. This is an SE library, and the idea is to make your life easier. And in general, anyone that wants to contribute directly on the creating new modules, let us know. We can help. And we have also a couple of time during the NIWeek, so if you need to talk in more detail with us about an application that we're doing, we're happy to help you with that.
So if you go to ni.com/decaf, there is all the information that you're going to need to get started with the framework, including these kind of presentations, a set of videos to walk you through what the framework does and how to work with it. And we're also available on there if you have questions for follow-on support after this week. There's a forum on there where you can ask questions.
Good.
Is there an Ethernet IP module?
Yes. We have one for tags and one for frames, so basically it uses our Ethernet IP library, and it's being called in settings directly from the library, from a module. So you can download them in the NPM. Also, please, before you leave, fill the survey. If you downloaded the app for NIWeek, you can fill the surveys for all the sessions that you visit from there. You have
And if you want to play around with it yourself right now, good luck with the Wi-Fi in here, but maybe when you get back to the hotel. If you go to VIPM, we are published right now on the Tools Network. just download the DECAF core package, and then any DECAF modules that you are interested in. Everything has the prefix DECAF, so quick search of that will show you everything.
And you see we have 2 for Ethernet IP.
Yep.
We have also one for the Profibus module.
And we're always working on new ones. Go to our GitHub page to see what we have in work. If you see something missing, well, contribute.
Well, thank you everyone for your time here. I hope you enjoy NIWeek and the rest of Alliance Day. And I think right now it's time for the lunch.